Hello everyone, recently I've heard someone stating that the cost of setting up a Raspberry Pi Zero for electronics projects can add up quickly. The common rationale for this misconception is that the initial setup requires a lot of peripherals, such as USB hubs, external keyboard, external monitor, and cabling, etc. This video will show you how to avoid these costs and get started with Pi Zero projects quickly. Pi Zero variants come with a USB on-the-go controller, which allows to power the Pi and communicate with it via a single cable. In this demo, I will be using a 64-bit Ubuntu 16.04 and the latest Raspbian Scratch Lite image as of this recording. This video assumes some familiarity with the Linux command line environment. I will try to explain as much as practically possible while attempting to keep the video length under 10 minutes. First, we'll start by verifying the integrity of the Raspbian image. Let's copy the SHA-256 checksum from the Raspbian website and save it in a text file. For consistency purposes, we'll use Raspbian image file name as the base name for the new file and add a .SHA-256 extension to it. Next, using grep and command substitution, we'll validate the output of the SHA-256 sum command called on the Raspbian image against the checksum we just copied. If you don't like all of the typing, refer to the check SHA-256 shell script in the link below. Next, we'll unzip the Raspbian image and check for our SD card location. In our case, it is /dev/mmcblk0. Next, we'll use the dd command to write the Raspbian image to the SD card. Make sure you don't have anything important saved on the SD card since it will be completely overwritten. Be extremely careful when specifying the input and output files for the dd command, since doing so incorrectly may destroy the data on your hard drive. Note that if specifies the source file and the off points to the destination of the device to be overwritten. Note that dd command by default does not provide progress updates, however we can still get that information by using the kill command. Calling kill on the dd process with user1 signal will print the current progress report without terminating the dd process. Once the image is done copying, let's mount the SD card and check the location of the boot and rootfs partitions. The boot partition will contain files needed to configure the device tree overlay for our on-the-go controller and to start the SSH server. The rootfs partition will have a file needed to configure static IP address for our connection. First, we need to enable the device tree overlay for our on-the-go controller. The device trees are a way to describe hardware layout as a hierarchy of nodes on Linux systems. With an enormous variety, especially in similar hardware, the device trees can grow unruly. A way to manage that without overriding an entire hierarchy after a new device was added is through a partial device tree mechanism called device tree overlay. To specify the device tree overlay for our on-the-go controller, we'll append the following line to the config.txt file: dt overlay equals dwc2. Next, we'll enable the kernel modules needed for USB networking by adding the following line to the cmd.txt file after root. Wait, modules-load equals dwc2, g_ether. Note that cmd.txt is a file in a single line format and there should be no new line characters added. Finally, we will add a blank file named SSH in order to enable SSH server on startup. The last part in configuring our Raspbian image before booting is to set up a static IP address. In order to accomplish this, we'll have to switch over to the rootfs partition on the SD card and add the following file: etc network interfaces. The 4 lines which are added to the interfaces file will configure the Pi to use a static IP address of 192.168.10.254. All we have to do now is to unmount the boot and rootfs partitions on the SD card, safely remove the SD card, insert the SD card into the Pi, plug in our Pi into our computer, and wait for it to boot. The default Raspbian installation will expand the SD card Linux partition on the first boot, therefore it may take a minute or two for the boot process to finish. In order to avoid a lot of headache caused by the resetting of the network address for your Pi, you'll have to disable the DHCP for the Pi connection. Once the boot sequence is complete and your computer recognizes the Pi as a network device, left-click on your network manager, go to Edit Connections, select your Pi connection, ensure that the Methods section under IPv4 Settings tab is set to Disabled, and the Methods section under IPv6 tab is set to Ignore. The last thing we have left to do is to set up port forwarding. Before commenting on the barren state of my firewall, please note that I have cleared my IP table rules for clarity purposes and I'm not connected to any networks while recording this. This is not how my firewall looks like, and I hope yours doesn't look like this either. Let's start by setting the value of proc sys net IPv4 IP forward to 1 and verifying it. Next, we'll verify that our USB IP address is set to 192.168.10.250. If not, we will set it with ifconfig command. Next, we'll set up the network address translation in IP tables for our PI's network. We'll insert a rule in the post-routing chain of the NAT table for our PI's Class C network with an address of 192.168.10.0 and send it to the masquerade target. Next, we'll insert rules into the forward chain accepting incoming and outgoing traffic to and from our PI's interface. Finally, we'll insert an input rule allowing incoming traffic from our PI's interface. Now we are ready to SSH into our PI using default credentials and get on with our projects. There is one more optional thing you can do, but it should be only done after you lock up your firewall. If you want to grant internet access to your PI, add a static route and set the default gateway to point to the physical interface of your PI. In our case, it is 192.168.10.250. You can do so by using the route command shown on the screen. That's all for this video. I'll see you next time.